Hi Rockstars, this video is part of the series of videos that we've done about understanding how energy is transformed and developing a mathematical equation, right, for energy at various points in the system. We started this discussion with the car that was going too fast under a tunnel, and it actually hit a surface and was launched into the wall of the tunnel, and actually ran into almost the top part of the tunnel. And that relationship between velocity and height determines how you shoot a basketball, how you kick a soccer ball, um, you know, what sounds you get when you drum, or when you how hard you play guitar. All of those relationships are associated with this energy transfer. So at this point, you should know how to describe the energy, like where is E1, where is E2 in this picture. Right, if I show you this picture, you can tell me where you might see E1, E2, E3, and you can even tell me what kind of energy, is this GPE, is this KE, is this GPE and KE, is this GPE1, is this KE1, is this GPE1 and plus KE1? All of that work should be done. If you can't tell me which of those options is right, please go back, watch the previous videos, and make sure that you're ready to be here, because we are into the deep work now. So in this video, I'm going to go through how to go from identifying the energy to actually substituting the variables. So for this, we need, so my screen cracked, and it's fascinating because now I'm doing this on my Chromebook, and it's not quite the same. So in this case, we're actually going to look at this example and write what so we're going to substitute the variables. So here at E1, you know that we have GPE1, still absolutely fantastic. When I change touchpads, you would think it's a tablet and I could write on it, but the tablet does not work with the video maker. So we continue to make awesome writing. All right, so here at E1, types of energy, it's got gravitational potential energy, it's got kinetic energy. So what does that mean? So in this case, the gravitational potential energy has a formula, right? Gravitational potential energy is mgh. So I'm going to say that this is going to be mgh because it's gravitational potential energy here at 1. And in fact, it is mgh1. The mass is not going to change at the different points. It's still the same cart here, here, and here. So we don't talk about mass at 1, mass at 2, mass at 3. The cart mass stays the same, so it does not need a subscript. This cart is moving on Earth. It's moving on the same planet or in the same gravitational field the entire time, so it does not need a subscript. If we were moving from Earth to Mars, we would need subscripts on these G's. But this cart is moving on the same gravitational field, so this cart gets to just have G. But H1 is different from H2, which is 0, and it's different from H3. So we need to make sure that we know that this case, we talk about GPE1, it's going to be for H1. So there's MgH1 plus KE1. Right? So we need to add the KE1. So for KE, it's 0.5, 0, 0.5, M. In this case, it's going to be V1 because the cart's already moving. Squared. So there's V1. And now I need to square it. Right? So that's how I substitute the variables, right? Gravitational potential energy depends on mass, the gravitational field strength, and the height. Back to the videos, where they're in the plane and everything's floating, that's the gravitational field strength thing. Back to the height videos where the people were falling on top of each other. Height affects that potential energy, as does mass. Kinetic energy, right? The variables that affect kinetic energy is velocity. We talked about that with the various car crash videos and looking at how going faster gave you different car crashes, and then the mass effects, how much kinetic energy objects have when they, right? The mass, if it has more mass, it's going to have more kinetic energy. So right now I have now substituted the variables in for E1, right? I thought about what kind of energy was there, and then I substituted the variables. So E1, right? And if I were doing this in a problem, I would have written out the gray step here, GPE1 plus KE1, but E1 equals E2, right? And then so I'm going to rewrite everything over here together. So MgH1 plus, because it's 0.5 mv squared. In this case, it's the v1 squared. It's the velocity here at 1. 0.5 mv squared. And it needs, of course, to be the velocity at 1. Right? Velocity here at 1 is going to be different than the velocity here at 3. It's going to be different than the velocity here at 2. So because we have different velocities, we need to each give them a subscript. So let's look at 2 now. So here at 2, there's no height, so there's not going to be any GPE, but this cart came rolling down this hill, so I'm sure it's going very fast now. So all of that energy from the top of the hill is now in cart 2, and it is 100% KE, right? So it's 100% KE. So the equation for KE again is 0.5 mv squared. So I have KE2 is going to be 0.5 mv squared. In this case, we're talking about the velocity here at 2. Okay, so 0.5 mv squared. We're talking about the velocity here at 2, where it's going the fastest. So it's actually 0.5 mv2 squared. So I'm going to set E1 equal to E2, right? We're not creating or destroying energy today. It's a closed system. So all the energy I start with, all the energy I end with. So E1 equals E2. Here I substitute the variables. I'm going to finish substituting the variables for E2. So at E2 it's 0.5. I'm going to squeeze this in maybe. V2 right, squared. So those are all multiplied together. So I have now substituted the variables. This is the step, right? Before I need to do this step before I can solve for the final velocity of the cart, or solve for this velocity that it started at, or solve for the strength of the gravitational field here on Earth, to get from energy to a height or a velocity or a gravitational field strength. I need to determine the types of energy and then substitute in the variables. So go ahead and try E2 equals E3, and we will come back and talk about that example in the next video. You got this.